Don't forget to subscribe and ring that bell.
Hey, hey, welcome back. And we are going to continue the journey on the Algebra 2 exam from June of 2023. We are going to finish the multiple choice. Man, what a beast. What a demon. This has been a nasty set of multiple choice questions. But don't worry, for two reasons. One, we always get a calculator. And number two, as nasty as this test is, we nastier. Yeah, we bad. We bad. Let's finish these multiple choice questions right now. Quick little reminder, each question is worth 2 points from the multiple choice section, and we do not get partial credit. It is either right and you get the 2 points, or it is wrong and you get nothing. Let's nail this now. Number 17. Marissa and Sydney are trying to determine if there is enough interest in their school to put on a senior musical. They randomly surveyed 100 members of their senior class, and 43% of them said they would be interested in being in a senior musical. Marissa and Sydney then conducted a simulation of 500 more surveys, each of 100 seniors, assuming that 43% of the senior class would be interested in being in the musical. The output of the simulation is shown below, but for the sake of fitting everything on the screen, it is to the right, okay? Now, what does that mean? That means what they just told us, each one of these dots here, okay, there's one here, there's two here, there's two here, there's one here, two, one, two, three, one, two. Each one of these dots and each one of these columns, one dot represents one simulation of 100 seniors. Okay, so for the sake of understanding what this really means, each dot, if I took this dot right here, this one right in the top, this one dot, that one dot represents a survey of 100 seniors. Okay, assuming that the average for each one of those dots would be about 43%. All right, is that important to solving this problem? Not really. I just want you to be able to interpret these graphs. What the question is they're asking us for the standard deviation, what it's closest to. We will not be able to calculate it exactly. The standard deviation, I'm down here, of the simulation above, of this table, okay, is closest to what number? Now, there is one thing I know, and this is how I do it, whether it's right or wrong, it gives me the right answer. The middle is probably, right around here, okay? Notice it goes to, this is probably 0.58, approximately, this last dot right here. And this dot here looks like it's right in the middle of 0.28. So from the first dot to the last dot, okay, from 0.58, the extreme dot on the right, minus 0.28, that covers 0.30. So the difference, okay, from here to here is 0.30. Okay. Now, that's the distance between the two. What I know about standard deviation is the following. There's the middle, and there's 3 standard deviations on the right. 1, 2, 3. And there's 3 standard deviations on the left. 1, 2, 3. So how many spaces do I have in between here? Okay. What do you mean spaces? 1 space, 2 space, 3 space, 4, 5, 6. So there are 6 little mini intervals, if you so to speak. 1, 2, 3, 4, 5, 6. There are 6 intervals that go across that total of 0.30. So if I take my 0.30 and divide it by 6, I get 0.05. And that's the length of each one of these. That is a length of 1 standard deviation. Okay? 0.05. Problem number 18 is another one of those problems that's it's kind of like an outlier problem. They really don't ask about even and odd functions too frequently on these tests. So this type of material doesn't get that much attention. 18 states for f of x equals cosine of x. Which statement is true? All right. Number 1, 2 times f of x and f of 2x are even functions. Then it says f of 2x and f of x plus 2 are odd functions. Then choice 3 gives us 2 options that are odd functions. And choice 4 gives us 2 options. And they're saying one is odd and one is even. Let's first state, how can I tell by visually looking at something if it's even or if it's odd? If it's even, it would reflect, that's an even, not ever. It would reflect over the x, or excuse me, over the y axis. If it's odd, it reflects through the origin. Now, I'm going to take choice 1 here. And choice 1 tells me I take 2 times f of x. That's f of x is cosine of x. So when they tell me 2 times f of x, that's really 2 times f of x, which is cosine of x. And if they tell me here f of 2x, if f of x is cosine of x, and they will put a 2x in here, that means I got to put a 2x here. Okay, so they're really telling me the cosine of 2x. They're saying both of those are even functions. They both reflect across the y-axis. Well, let's graph them. Let's see. Turn this on, this calculator. I'm going to go to y equals. And I'm going to graph 2 cosine of x. And I'm also going to graph the cosine of 2x. Okay, if I graph both these things, okay, this is the first one. That appears to be reflected over the y-axis. Now let's see this one, the red one. That is also a reflection. They are both even. What do I mean there, sillies, when I say it reflects across the y-axis? Well, let's do this here. Let's get a little crazy. Here we go. Oh, that's a nice big image. My y-axis, okay, that would be nice. It'd be nice if I hit this and it went away. But, what are you going to do? There we go. This is my y-axis. Let's look at the blue one for right now. Okay, the blue line, this part right here that I'm highlighting in blue, okay, that is a reflection exactly right here, right across that green line. And the red one, okay, that I'm highlighting in this kind of purple, is a reflection over the green line as well, which is the y-axis. They're both reflection of the y-axis, so they're both even. So my choice, come on. Those are both even. It's choice 1. Okay, it is choice 1. It's nasty. Okay, thank God. We are back to just some basic algebra. We are going to use a graphing calculator to solve this one. I could do this algebraically, and I mean, perhaps I should, but this is a multiple choice question. If it were a test, use a calculator. You don't have to show your work. So what happens when I have an equation that has one variable? What do I mean? There's only x. There's not an x and a y. There's just an x. I can put this in y1, and I can graph this part in y2, and I could just see where they intersect. And that's exactly what I'm going to do. Okay, so let's go back here. We'll go to y equals. I'm going to clear both of these out. And I am going to put in y1, the left side of that equation. Ready? So that was, I'm going to hit alpha y equals a create a fraction. X plus 3 over x minus 5 plus another fraction, which is 6 over x plus 2. And the right side of that equation that was given, it's another fraction. It's 6x plus 10 over, oh man, 2 parentheses, x minus 5 times x plus 2. Now, if I graph this, I should see a blue graph and a red graph. Here's our blue one. Oh, that's so pretty. Here's the red one. Okay, it looks like I saw an intersection right there. That doesn't look like it. Oh, there's another intersection. Okay. Well, it looks like, okay, I have an intersection right here. They cross. And it looks like I have an intersection right here. Looks like they cross. All right, well, let's use the intersect function. So how do I do that in the calculator? I go to second, which is this blue button right here, and then trace, because above trace in blue it says calculate. And I want to calculate the intersection, which is choice 5. Now, all I got to do is move my little spider dude closer to whatever intersection I want. Since I'm already here, I'm gonna come down to this one. Now, don't just put it close and think that's the answer. Get it close and hit enter 3 times. 1, 2, 3. Okay, well, it looks like 3.844 and negative 4.89. I only want the x-axis. Okay, so it's 3.84. Did I put this incorrect? Man, let me see. X plus 3 over x minus 2 plus 6 over x plus 2. Oh, it's x minus 1. Yeah, that's correct. Dang it. Look at me go. It's 6 plus 10x. The x is with the 10, not the 6. Oh, man, that was a good catch. All right. I was about to say, none of my answers had a decimal in it, so it looked a little weird. It looks very similar, but I have one intersection there. And see, there's no intersection at this point. Okay? There's no other place they cross. So I only have one intersection point right there. Wow, that was a good catch. How did I know that? Look at my answers. When I came up with that x value, it was 3.8 something, and that was not here. So I knew that I mistyped something in. So let's do the intersect function one more time. Second, trace, and I want to go to intersect. I could just hit the number 5. And now, I'm just going to keep going left until, there it is. Right close here and hit enter 3 times. 1, 2, 3. Negative 6. That's it. I just want the x-axis, or the x value. Negative 6. That's it. No other point do these intersect, okay? So I have one answer, negative 6. If I were to do this algebraically, you might get negative 6 and the number 5. But notice, the number 5 is one of those answers that's an extraneous solution. It won't work. How come? If I put the number 5 in here for x, 5 minus 5 would give me a 0 on the bottom of a fraction. I cannot have a 0 in the denominator. So 5, if I did this algebraically, I would get x would equal negative 6 and x would equal 5. But 5 is an extraneous solution. It does not work when I try and put it in and check it. The calculator and the graph showed me one intersection point. It does not show me the one. That doesn't work. Number 20. Given that x and y are positive, which expressions are equivalent to x cubed over y? Again, you know, this is overkill. All right, but it's just testing you on 2 things. Your ability to make radicals into exponents, and then your math with exponents. What do I mean? Okay, let's look at the first one here. If I have a -1, that means I'm flipping everything inside the fraction. All right? Let's do that better. Okay, the exponent to my y is currently a 1. Exponents raised to exponents, I need to multiply. So if I multiply -1 times 1, I get -1. -1 times 3 is -3. Anytime I have a negative exponent, it needs to flip. This will come up, become x to the positive 3, and this will come down and become y to the positive 1. That's the same. Guess what? Bing, bing, bing. Number 1 works. My answer should have 1 in it. 1, 1, 1. Okay, choice 3 does not have option 1 in it, so that can't be the answer. Number 2. Let's check number 2. Okay. I have this right here. Okay, top down, bottom out, which means I can make my x have a fraction exponent. The bottom of that fraction, the denominator, is what's on the outside, my 3. And the numerator, which I'm going to put a big N there for numerator, is what's here, the 9. All right. Again, y to the -1. If I have y to the -1, I need to flip it to make the exponent positive. So now I have 1 over just y. All right, well, hey guys, here's a little secret. 9 divided by 3 is 3. So I have x cubed times 1 over y. That's x cubed over y. Look at that. It's the same thing. Choice 2 works. So 2 should be my answer. That's not for option 2 down here. There's no Roman numeral 2. And 2 here. So it all comes down to our third choice. Either number 3 works, and my answer is going to be option 4, or number 3 doesn't work, and it's only going to be 1 and 2. So let's pick, oh my goodness gracious, number 3. Let's make this into a fraction exponent. So we got x to the 6th times. Okay, the denominator is the 1 on the outside. 4. The numerator is the 1 on the inside. Okay. 8 divided by 4 is actually 2. So that's literally y squared over x cubed y to the 3. All right, well, let's simplify this. 3 x's go away, and 3 of these x's go away. So I now have x cubed on the top. 2 of these y's go away with 2 of these y's, so I now have y to the 1 on the bottom. That's the same thing. Like, how dare they make you do 3 problems and have them all work? Oh, man, I would like to slap someone in the face with a fish, whoever wrote this test. Thank you for giving us something easy. The only thing is, you got to remember the process. 21 says, given the inverse, f -1 of x, this just means the inverse of f of x. That's all that means. It's just notation. Okay? The inverse of f is 2/3 x plus 1/6. Which function can represent f of x? All right, well, in order to go from your original function to the inverse, or back, this is both ways. It doesn't matter which one you start with and which one you want. The process is the same. I switch my x's and y's. That's the first step. And the second step is just then solve for y again. Okay, make it y equals. So if I look right here, f of x is the same thing as y. These are the same thing as my y's. So if I rewrite this, I really have y equals 2/3 x plus 1/6. So I'm literally going to switch all my x's into y's and vice versa. all my y's into x. So this will become an x, 2/3. This will become a y, plus 1/6. That's it. That's the only thing I change. And now I just solve for y. That's it. So if you understand, if you remember the process, the math is really easy behind it. So let's subtract. Okay, shall we? Subtract 1/6 first. Subtract 1/6. Boom. So I got x minus 1/6 equals 2/3 y. Well, in order to get rid of a fraction, I'm just going to multiply by its reciprocal. So I'm going to multiply this times 3/2. These cancel, and I just have my y. What I do to one side, I've got to do that to the complete other side. So I multiply this by 3/2, and I multiply this one by 3/2. Okay, so I've got 3/2x minus, all right, 1/6 times 3/2 is 3/12, and that reduces to 1/4. So minus 1/4. There you go. That's it. And it looks like that is choice 3. Boom. Oh, how I hate this test. How many equations below are identities? All that really means is which one of these or how many of these actually work. They're true. They're identities. They're identities of each other. So how many of these is the one side equal to the other side? All right, well, that's you know, let's figure it out. But I've got to check all 3 of these. All right, so let's start with the first one. I know, okay, if I combine these things, because I'm not, I got to FOIL this one. I've got x squared minus y squared. Okay, plus, if I square this, I've got to square everything on the inside. Square the 2, that gives me 4. I square the x, I square the y. All right, that's one term. So that's 4x squared y squared. Yeah, I can't combine anything anymore. That's it. That does not equal x squared plus y squared. So it's not, this one is not an identity. They are not equal to each other. All right, let's pick the next one. All I've got to do is combine like terms because there's only a plus between them. We're not squaring any of the parentheses. So let's check this one. Let's do this right here. I got x minus y plus x squared minus xy plus y squared. Can I combine anything? Do I have any other x's? No. Do I have any other y's? No. Do I have any other x squareds by themselves? No. Do I have any term that has an xy in it? No. Do I have any term that's a y squared? No, that's it. That is definitely not equal to x cubed, y cubed. Bye-bye. No. Oh, you nasty son of a gun, you. The next one, okay, I've got to multiply this times this because there's no plus or minus between the parentheses. Then when I get that answer, I got to multiply it times this. All right. So x minus y times x minus y. If I FOIL that, I get x squared minus xy minus another xy plus y squared. So I get x squared minus 2xy, because I'm going to combine these, plus y squared. That is these two multiplied together. Now I've got to multiply it times x squared plus y squared. So I'm going to take this and multiply it times x squared plus y squared. Yeah, that's not going to give me this right here. I mean, if you want me to just check that out, let's multiply everything times x squared. So I've got x to the 4th is the first one, times negative 2x cubed y. Now times this last one, it's plus x squared y squared. Now let's do these, the y squared to all three of these. Okay, y squared times x squared is plus x squared y squared times a negative 2xy, so it's negative 2xy cubed, and then plus y to the fourth. So it's saying it's just equal to this term plus this term. That would mean all of this would have to cancel out. It does not cancel out. This is a negative 2xy cubed and another negative 2xy. That would give me negative 4x cubed y cubed. They don't cancel. If one was a plus and one was a minus, it would cancel. Ah, you know, we did a problem like this earlier where all three were an answer. Here, none of the three are an answer. How many are identities? None. That's dirty. Again, screw the person that made this test. Not because this is difficult, but it's an outlier for one reason, and I will explain why in a moment. If the focus of a parabola is at 0, 6, okay, focus, and the directrix is at y equals 4. Okay, so let's plot this. Okay, 0, 6, 1, 2, 3, 4, 5, 6. Here's 6. This is the focus. Going to do this in purple. Right here, it's the focus. It's the focus, which is 0, 6. And the directrix is at y equals 4, which is right here. What's the equation for the parabola? We always write the parabola as y equals. Look, they got y squared alone, x squared alone, y squared alone. So we're going to have to manipulate the equation. Well, I mean, like, just every question goes above and beyond unnecessarily. If you know this, then you really know math. I get that part. But for those people that like work hard to just try and stay above water, this is a difficult test. Okay? In order to come up with the equation of a parabola, which this is not on your reference sheet, okay? This is the vertex form of a parabola. My vertex is my h and k value. My vertex is always exactly in between the focus and the directrix. So that's at the point 0, 5. So my h is 0 and my k is 5. So it's x minus 0 squared plus my k value, which is 5. So the last question is, well, then what the heck is this A? A is 1 over 4c. Not to confuse you, but I'm going to define one letter using another letter. So the million-dollar question is, what's c? C is always a distance starting from your vertex going to the focus. I am moving up 1. So that's plus 1. So my c is a positive 1. So 1 over 4 times c, which is 1, that's 1/4. That's my a value. That is going right here in my equation. Now, let's clean up what we can. Y equals 1/4. X minus 0 is just x squared plus 5. Okay. I am not going to square the y and then square the other side. That's just insanity. I have an x squared here. Let's try and get the x squared alone. And this is the extra step going above and beyond. First, let's subtract 5 from both sides. Y minus 5 equals 1/4 x squared. Now, if I want to get the x squared alone, I got to get rid of the 1/4. The opposite, okay, 1/4 is like dividing by 4. So I'm just going to multiply by 4. This will cancel with this, and I have x squared. What I do to one side, I have to do to the whole other side. 4 times y is 4y. Minus 4 times 5 is 20. X squared is 4y minus 20. Oh, look, oh my God. Oh my goodness. We do wrong. We did nothing wrong because I didn't even have to go to this above and beyond step. Oh, I didn't even have to do this. Okay, what happens when I multiply this side by 4? We got x squared equals, they didn't even distribute this 4. So they make you do math, but then don't finish the math. Ugh. X squared is 4 times y minus 5. X squared is 4 times y minus 5. Nasty. Man, can we please be done with this? Last question. Number 24. John and Margaret deposit $500 into a saving account for their son on his first birthday. They continue to make a deposit of $500 on the child's birthday, with the last deposit being made in the child's 21st birthday. If the account pays 4% annual interest, which equation represents the amount of money in the account after the last deposit is made? Now look at my answers here. S. 21 is the n value, we call that. When I want to total up a bunch of things, S of n is the equation that's provided to me on the reference sheet. So let me show you the reference sheet right now. Okay, this is the reference sheet. If I scroll down, and this is the actual reference sheet from the June 2023 exam, and it's still going to be the same. Okay, wow, that goes fast. Look at, let me move this for a second. I scroll down. I want to add up a geometric series, okay? It's not going up by the same amount. I'm looking at this S of n. This is the tell right here, okay? I'm going to use this. Oh, wow, that was fun and interesting. I'm going to use that right there. So let me take that and put that on our test right now. Oh, I've used this twice. Why are they telling me that R cannot be 1? Because if I put a 1 here in the bottom, okay, if R was 1, that's just them just safeguarding themselves. If R was able to be 1, and I put a 1 here, 1 minus 1 is 0, and the bottom or denominator would be 0, and it wouldn't work. Okay? So what we have to understand is a little bit something about geometric series. A of 1 is your first number in your series, or the first number in my list. In this case, it's the first deposit, $500. So when I start this, I have S of n. I got this fraction here. All right? In this case, n is the number, okay, of deposits. They're going to, this 21st birthday, that means they're going to deposit 21 deposits. So let's make our n 21. I mean, it's not really critical because every answer has S of 21 down here. But for every A1, I'm going to put $500. 500 minus 500. Now, we have R here. R is the rate. Okay, R is our rate. We are going to take, okay, R is 1 plus, I guess, the percentage. Okay? But I wanted that in decimal form. 4% is the same thing as 0.04. So let's put that right here, 0.04. So when I combine those, it's 1.04. That's the number that's going to go in for this R right here. Okay, that'd be nice if that went to blue, like a, and this R. Okay, so 1.04. And then at the bottom, it's 1 minus my R again. And of course, the n is 21. See, the n is 21 here. That was an n. There's also an n here. It's the exponent to my r, 21. And that's it. You just have to set it up. And that, my friends, does not look like it's on the answer sheet, does it? How come? Because, of course, they're going to go an extra step. That is the answer. What's the one thing they did? And let me clear some room here. What's the one thing? Yeah, that's nice. What's the one thing they did to the answer that we came up with? to make it look like one of the answers in the multiple choice? Because, you know, it can't be easy. God forbid you come up with a right math answer and it's not there. They factored out 500 from both these terms in the top. So if I factor out a GCF of 500, I'm left with 1 minus, okay, then 500 divided by 500 gives me 1. 500 divided by 500 here is 1 times 1.04 to 21 over 1 minus 1.04. And of course, right here, 1 times anything is itself. Again, I touched the red ink there. That would be great if it worked, and I did have to touch it twice. 1 times anything is itself, so we really don't need the 1 right here. Look at that. That's the answer. That's choice 3. Man, I hope the short answer is a little bit more bearable than the multiple choice here. This is a horrible test.
Don't forget to subscribe and ring that bell.